Welcome to the end of chapter 4, where we're going to finish by talking about rational functions. So we started by talking about quadratics, parabolas, and then we said, okay, quadratics are if we have a squared term. What if we have higher exponents? That was polynomial functions. And now we're going to say, what if we divide two polynomial functions? And that's going to be rational functions. So let's start with a motivating example. October, don't you dare start chewing on that plastic. Anyway, so we have this situation over here. We've talked about total cost. We've talked about marginal cost. Now we're going to talk about average cost. All right, so average cost is similar to the others, but a little different. So total cost of producing a certain number of items, we talked about that before. That's very useful. It's how much do we got to pay if we want to produce a certain amount of items. Marginal cost, remember marginal cost? That was where we talked about like what's the additional cost of producing one extra item. And it's kind of related to average cost, but not exactly the same. So here we're going to be talking about average cost. So we'll start with the definition. The average cost of producing Q items with a total cost C of Q is just, so the average cost is just the total cost divided by how many there are. A great day for chewing plastic, everyone. Thank you, October, for sharing this. So we're going to find average costs. I teased a little bit that rational functions are just dividing polynomials by each other. Well, let's see it in action. Suppose that manufacturing an item has fixed costs of 4,000 and per item costs, marginal costs, here we have a constant marginal cost. That's not always the case. But a per item cost of $20 per item. Find the average cost per item when 250 items are produced. So first we need the average cost function. We need to find the average cost, which is based on how many items we're producing. Right? Because the more things we're producing, usually we're going to be able to, each one's going to be on average cheaper. Because we're basically utilizing those fixed costs better when we produce more items. So AC is just the total cost divided by how many things we're producing. That's just our formula. Nothing new there. But to go any further, we need to know what our total costs are. Well, how can we find our total costs? Well, that's kind of like what we did earlier in this class. We know we have a fixed cost of 4,000, so we always have to pay that 4,000. No matter how many items we produce, we're always paying that 4,000. And we're also having to pay $20 per item, maybe in labor, in materials, whatever. So we have additional costs of $20 for every item, and we're calling our items Q. So if that's the total cost, average cost is just total cost divided by how many we're producing, and our total cost is 4,000 plus 20Q. There we go. That's it. We're done. Well, we're done with the first half. Quick word of warning. Do not write this down. We cannot cancel these. You can only cancel in a fraction if there's the same factor. And we can't factor out a Q from this whole numerator, so there's no canceling that can be done. We don't have common factors here. You can only cancel fractions when things are factored. Anyway, so we need to find the average cost of 250 items. So we just plug in 250 into this average cost function. 4,000 plus 20. We have a function that tells us, and we're just using this function to find a value. You type this into a calculator, that should be 9,000 over 250, which is going to be 36. 360. Let's use a calculator. All right. 9,000 divided by 25. 360. Okay. So Oh gosh, it is 36. I was thinking this answer is crazy. So I forgot to write a 0 in the denominator here. Because if the average cost were 360, that'd be super weird. And again, let's add units to our answer. The average cost is $36 for every item. An average cost of 360 per item would be so crazy if each item really just cost $20 per item. Now, we would always expect the average cost to be higher than this marginal cost because the average cost takes into account the fixed cost, right? So we're always having to pay that $4,000. And that's why I said the average cost is going to get lower the more things we produce. We're utilizing that fixed cost of 4,000 better. Let's graph this function on Desmos. 4,000 plus 20Q over Q. I'm going to use X's here, but just because I don't want to confuse the computer, I think it can maybe handle Q. 4,000 plus 20X over X. Okay, that looks good. And we can't see anything. Why not? Well, because our costs are at least 4,000 at the start. So we're going to go over here to the wrench icon and say, well, the question asks us when we produce 250 items. Remember, our inputs are how many items. We're going to need to look to at least 300 items. And then our costs, our average cost, I don't know, let's start at, 100 or something. So you can see that if we're not producing very much, I'm going to zoom out some more. Oh, this function does have negative values, but for this application, we're not going to worry about that. So yeah, you can see that if we're not producing very much, the Y value, the average cost, is very, very high, which makes sense, right? If we're producing one item, well, we already have $4,000 in fixed costs, so the average cost of one item would be through the roof. But once we start producing a lot of items, the average cost comes down. What do we think this is gonna go in towards, right? If we produce 619 items, the average cost will be $26.46. If we produce a very, very, very large number of items, what do we think the fixed cost is going to approach? The average cost. Let's see. It's getting really close to a number. It's getting really close to a number. We could zoom out a ton. What is that Y value getting really close to? Getting really close to the marginal cost. We'll talk about that in the next video. Something called an asymptote. There's another one up here. As our input gets really close to 0, the output's going off to positive infinity. You got that to look forward to. Anyway, so we graphed it on Desmos. Cha-ching. We can see what's going on. The more items we produce, the more our input increases. The average cost is going down. I always say this makes sense. It makes sense to me, but that doesn't mean it makes sense to anybody else. But why this should make sense is, right, again, we're just utilizing our resources better, essentially. Let me know if you have any questions about this, and this is a motivation for rational functions. They're very useful in average cost because, surprise, this is a rational function right here. A polynomial, in this case a linear function, divided by another polynomial, in this case also a linear function. Watch the next video and let me know if you have more questions. Have a good one. Bye-bye.